The Great Pyramid of Giza is widely celebrated as one of the most extraordinary monuments in human history. Mainstream historians claim it was built as a tomb for the pharaohs, particularly Khufu, to immortalize them after death. As the only surviving wonder of the ancient world, the pyramid is often described as a feat of architectural genius and mathematical precision. Yet, the tomb theory faces significant challenges. The pyramid lacks many features typical of royal tombs. There are no ornate burial artifacts, no decorative wall paintings, no mummies, and no elaborate coffins. The absence of these elements raises the question, could this structure have served a purpose far beyond mere burial? One of the most striking aspects of the pyramid is the materials used in its construction. The outer casing stones were made of highly polished limestone, which would have reflected sunlight brilliantly while insulating the interior. Dolomite was used in specific internal areas. Modern science recognizes dolomite as a material that can conduct electricity more efficiently under pressure. Granite, used in the inner chambers and lining underground tunnels, contains high amounts of quartz crystals and traces of metal along with slight natural radioactivity. These properties allow piezoelectric effects, where mechanical stress generates electrical charge. When combined with strategic architecture, these materials could create conditions suitable for energy generation. The scale of the pyramid is another point of fascination. In Egypt alone, there are over 118 pyramids, and the Great Pyramid required an estimated 20,000 workers laboring daily for at least 20 years. Considering the amount of labor, coordination, and precision involved, it is challenging to reconcile the pyramid as merely a tomb. Why would a civilization dedicate such enormous resources to entomb a single individual, especially given the lack of artifacts or inscriptions directly referencing the pharaoh Ensid? The possibility arises that the structure served a far more practical and functional purpose. Ancient civilizations are often underestimated in their technological capabilities. Knowledge and innovation are not necessarily linear. They can appear, disappear, and reappear across centuries. Could the ancient Egyptians have possessed knowledge of electricity and energy manipulation long before our modern understanding? One intriguing historical artifact is the Baghdad Battery, discovered in Iraq in 1934. This artifact, dating back approximately 2,000 years, consists of a ceramic pot, a copper tube, and an iron rod. When combined with an acidic liquid, it generates a small but measurable electrical current. Experiments using grape juice or lemon juice confirmed that this combination can produce electricity, demonstrating that chemical methods for generating power were understood long before modern science officially recognized them. Returning to the Great Pyramid, there are multiple architectural features that defy conventional explanation. The pyramid contains angled shafts and passageways that descend deep underground, far beyond what would be required for a traditional burial chamber. Massive 20-ton swivel doors, engineered with incredible precision, allow for movement with minimal effort. The polished limestone casing stones reflect light and provide insulation, suggesting an awareness of energy control rather than mere aesthetics. Inside, dolomite and granite line critical areas, providing natural conductivity, piezoelectric effects, and even air ionization due to the slight radioactivity of granite. This combination of materials and design could, theoretically, facilitate the generation and transmission of electrical energy. Nearby, the Serapeum houses 20 enormous granite boxes, each weighing roughly 100 tons. Traditional Egyptologists claim these were sarcophagi for sacred bulls, though the size, weight, and precision of these boxes make them unlikely to have been mere burial containers. Each box is aligned within a tolerance of a 10,000th of an inch, comparable to modern industrial standards. Some researchers suggest these boxes could have functioned as capacitors or energy storage units. Evidence supports the idea that even small structural interruptions, such as cracks, would compromise their functionality, consistent with the theory that they were meant to channel or store electrical energy rather than house biological remains. In 1993, the Queen's Chamber, previously inaccessible, was explored using remote cameras. Inside, copper wiring remnants and floor markings resembling schematic instructions were discovered, suggesting that this chamber may have been used to direct electrical currents. Copper, being an essential conductor, could create a potential difference across the chamber, essentially forming a primitive generator. While the wiring itself has disappeared, the layout and remaining traces indicate a functional design rather than ceremonial purpose. The location of the pyramid also appears strategic. It sits above a convergence of telluric currents, points where natural electromagnetic forces are concentrated. Underground rivers and aquifers, including the ancient course of the Nile, could have provided kinetic energy sources. Water interacting with limestone and quartz would create piezoelectric or electrochemical effects, allowing natural forces to be converted into electrical energy. This theory aligns with the idea that the pyramid functioned not just as a structure, but as a system designed to harness, store, and potentially transmit energy. As we explore further into the pyramid's mysteries, the question becomes not just how it was built, but why. The combination of materials, design, and geographic placement creates a compelling argument for a functional purpose beyond burial. Could the Great Pyramid have been an ancient energy generator, capable of harnessing and transmitting power to its surrounding civilization? The evidence suggests that we may be only scratching the surface of understanding the true capabilities of ancient Egyptian engineering. Continuing our exploration into the mysteries of the Great Pyramid, the concept of energy generation takes center stage. If the Great Pyramid was designed with functionality in mind, the materials and structural choices become far more intriguing. Granite, for example, lines the subterranean chambers and tunnels. The quartz within this granite is piezoelectric, meaning it produces an electrical charge under mechanical stress. Ancient builders may have intentionally used the weight of the massive stones themselves to create pressure, inducing electrical currents. This would be a simple but highly effective way to generate energy on a large scale, using the very materials that form the pyramid structure. Furthermore, the pyramid's limestone casing stones, when polished, reflect sunlight intensely. While aesthetically impressive, this reflective quality could have been functional, keeping the interior temperature stable and potentially contributing to energy generation or storage. The interaction of sunlight, air, and the pyramid's conductive materials could have produced conditions conducive to building and maintaining electrical potential within the structure. Nearby, the Serapeum's giant granite boxes are a puzzle. Standard explanations suggest they were burial sarcophagi for sacred bulls, yet their size, weight, and construction precision challenge that notion. Each box is extraordinarily flat and precise, crafted from granite sourced hundreds of miles away. If these were capacitors or energy storage units, the uniformity and lack of structural imperfections would be essential. Modern engineers would require the same level of precision to maintain effective electrical storage, or to avoid interruptions in an energy system. The Queen's Chamber is another fascinating piece of this puzzle. Discovered after remaining inaccessible for millennia, this chamber contained copper wiring and floor models resembling schematics. Copper is crucial for electrical conductivity, and the layout suggests the chamber could have functioned as a generator or directional energy device. A metal coil in one area could produce a localized magnetic field, transferring energy to other parts of the structure. The chamber's design hints at a sophisticated understanding of electromagnetism, even if the precise methods remain lost to history. Now, consider the pyramid's geographic placement. Located directly above telluric currents, regions where Earth's natural electromagnetic energy is concentrated, it would be an ideal site for harnessing natural energy. The ancient Nile, which once flowed closer to the pyramid, could provide kinetic energy. Water, moving through underground channels, interacting with limestone and quartz, would generate piezoelectric and electrochemical effects. This combination of natural forces and material properties creates a plausible system for large-scale energy generation, potentially even wireless energy transmission. Connecting this to modern science, Nikola Tesla's experiments in the late 19th and early 20th centuries are remarkably relevant. Tesla sought to transmit energy wirelessly using high-voltage, high-frequency electrical currents. At the 1893 World's Fair, he demonstrated wireless illumination of lamps. His Wardenclyffe Tower experiments in 1903 reportedly transmitted energy over long distances, lighting up the night sky. Tesla envisioned a global system of wireless energy transmission, a concept that mirrors the hypothetical function of the Great Pyramid. Could it be that ancient Egyptians had discovered a method for similar energy transfer centuries before Tesla? The parallels between Tesla's work and the materials, design, and placement of the pyramid are striking. The pyramid is also aligned precisely with the cardinal points. Its slight eight-sided shape may enhance electromagnetic properties, similar to modern antenna designs. Modern measurements show unusual heat signatures and electromagnetic anomalies around the pyramid, suggesting the presence of energy phenomena. Ancient Egyptian art, including the Dendera light reliefs, depicts objects resembling bulbs, wires, and receivers, hinting at symbolic or practical understanding of electrical principles. These depictions may indicate that light and energy were understood and represented symbolically, even if the practical application was later lost. Another element is the potential capstone of the pyramid. Many researchers theorize that it was originally made of gold, a highly conductive material. This would have allowed the pyramid to channel electrical energy upwards, possibly into the atmosphere, analogous to Tesla's wireless energy experiments. Combined with the telluric currents below, the piezoelectric effects from granite, and the chemical properties of limestone and dolomite, the pyramid could theoretically function as a massive energy generator and transmitter. Moreover, the Queen's Chamber and other internal passageways suggest a system designed for repeated use or maintenance. Unlike traditional tombs that are sealed permanently, the pyramid seems to allow access to critical internal areas. This would make sense if it served as a functional energy system that needed periodic adjustments or monitoring. The absence of soot from fire torches inside the pyramid also raises questions. If the chambers were used as tombs, some evidence of fire-based lighting would be expected. Instead, the design seems optimized for electrical illumination and energy processes, rather than ceremonial rites. All these elements, materials, alignment, chambers, tunnels, water interaction, and symbolic art, build a compelling case. The Great Pyramid may have been more than a monument to the dead. it could have been a sophisticated energy infrastructure. Its design incorporates electrical, mechanical, and environmental principles, suggesting a level of scientific understanding that challenges conventional views of ancient civilizations. If this theory is correct, it changes the narrative. The Egyptians were not merely builders of monumental tombs, but pioneers of energy technology, whose knowledge was lost to time but preserved in stone and symbol. Continuing from where we left off, we must now explore the broader implications of the Great Pyramid functioning as an energy system. If the structure was designed to generate and transmit electricity, then the Egyptians were working with principles that would not be rediscovered for thousands of years. From copper wiring in the Queen's chamber to the piezoelectric granite and pressure-sensitive dolomite, every material seems carefully chosen to harness natural and mechanical energy. The combination of underground water, precise construction, and alignment with telluric currents could provide the foundation for a sustainable energy system, one entirely independent of fuel or combustion. The possibility of wireless energy transmission is particularly fascinating. Nikola Tesla, the inventor of the Tesla coil and a pioneer in electromagnetic theory, envisioned a world powered without wires, where energy could travel through the atmosphere. Tesla demonstrated in 1893 that electrical currents could illuminate lamps remotely, and at Wardenclyffe Tower he attempted to transmit energy over long distances using resonance. The parallels between Tesla's principles and the pyramid's potential functionality are striking. Could the ancient Egyptians have achieved a similar effect using the pyramid as a resonant transmitter? The pyramid's height, materials, and alignment would allow it to channel energy upward, potentially into the ionosphere, where it could then be distributed to receivers in the surrounding civilization. Obelisks and other tall structures in Egypt may have served as these receivers. If topped with quartz or metallic elements, they could capture the energy transmitted by the pyramid. Ancient Egyptian reliefs, such as the Dendera-like carvings, depict what appear to be bulbs with internal filaments and external coils, suggesting symbolic or practical knowledge of electrical transmission and reception. These artistic depictions, when viewed alongside the pyramid's material and structural design, provide intriguing evidence that the Egyptians understood and utilized energy principles that modern science has only recently confirmed. The scale of such a system implies that energy could have been used for illumination, mechanical devices, or other purposes within the civilization. If true, this rewrites the traditional understanding of ancient Egypt, presenting a society capable of technological feats far beyond what mainstream history recognizes. This is not merely speculation. The evidence, in the form of construction materials, architectural design, geographical placement, and symbolic art, all supports the possibility of practical energy use. Consider also the precision of the internal chambers and passageways. The Queen's Chamber, King's Chamber, and subterranean tunnels are aligned and engineered with millimeter-level accuracy. Such precision would be critical for the stability of energy currents, minimizing interference and energy loss. The geometry of the pyramid, slightly eight-sided, may optimize resonance, amplifying and directing energy in a controlled manner. In modern engineering, resonance and frequency matching are essential for efficient energy transfer. Principles that may have been applied intuitively or deliberately by the pyramid's architects. The loss of knowledge over millennia adds another layer to this mystery. Ancient writings rarely mention the construction of the pyramids in explicit terms, possibly indicating that such technological knowledge was deliberately hidden, forgotten, or considered sacred. Over time, the original function may have been lost,
leaving behind a monumental structure whose original purpose became obscured. Only the combination of surviving materials, architectural ingenuity, and symbolic representations offers glimpses into the past capabilities of this civilization. In conclusion, the Great Pyramid of Giza may have been more than a tomb. Its design, materials, location, and associated artifacts suggest it could have functioned as a large-scale energy generator and possibly a wireless energy transmitter. The implications are profound. An ancient civilization, thousands of years ago, may have harnessed principles of electricity, resonance, and electromagnetic transmission, leaving behind monuments that are still unmatched in precision and sophistication. If these theories hold any truth, the Great Pyramid stands not only as an architectural marvel, but also as evidence of lost scientific knowledge that challenges our understanding of human history. The mysteries remain. Why were such specific materials chosen? Why the chambers and tunnels were designed for access? Why the pyramid aligns perfectly with cardinal points? Why nearby obelisks exist? And why artistic depictions suggest advanced electrical understanding? Each unanswered question increases the plausibility that the Great Pyramid served a functional, practical, and perhaps revolutionary purpose: generating, storing, and transmitting energy. The possibility that ancient civilizations understood and applied concepts akin to wireless electricity reshapes how we view history, innovation, and the true potential of human ingenuity. If you've watched this far, don't forget to subscribe to the channel. See you in another mysterious event.